Okay, so welcome everyone for today's class. So today we'll be learning about mathematical notations, uh, constraints, and pseudocode. Basically, these all are important terms. These three things are important because it's not that you should know maths in depth, but these basic math notations you should be aware of. So we'll be discussing about that. We'll be learning about those things. We'll look into what are constraints in programming languages. What is a pseudocode, right? How to write pseudocode? What is a good pseudocode? We'll be learning about that. Okay. Just confirm, guys, have you seen these symbols anywhere in your 12th or 10th class, like maths? Yes, right. What is a symbol? What is a symbol? What does this stand for? This is summation. Okay. And what does this stand for? This is pi. Okay. But this is not your pi, like what you have learned so far, that is 22 by 7, what you have learned in your math classes. This is different. We'll learn about it. Have you seen this symbol? These two lines. Yes, that is modulus or absolute also you can say. And this is factorial, right? Okay. So this mod and this modulo, have you learned about the modulo operator? Have you guys learned about the modulo operator? Yes. Okay. So this is totally different. This modulo operator and this mod is different, right? The purpose of both of them is entirely different. All right. Okay. Now let's start with the session. So the first symbol that we'll be learning is summation. Okay. So what is summation basically? What is summation? What is summation? How many of you guys know what is summation? Summation is a mathematical notation used to denote the addition of a sequence of a number. So basically, you can add a sequence of a number from a one particular number to another particular number. This operation totals all the numbers in the sequence and is typically represented by the Greek letter sigma. So this symbol is known as sigma. So this is known as what, guys? This is known as sigma. This is known as sigma. Okay. Example of summation. Suppose you want to calculate the total of first 100 natural numbers. You want to find the sum of the 100 natural numbers using the summation notation. This can be represented as sum equals to summation of I equals to 1 to 100 I. What does that mean? I'll explain it, how we represent it, how we can expand it, how we can write the sequence. I'll go through it. So summation of I equals to 1 to 100 I. This means you add all the numbers from 1 to 100. So let's say if I write summation of I equals to 1, right, 200 I, which should be equals to, if I expand the sequence, that is 1 plus 2 plus 3 plus till 99 plus 100. So this is the sequence of it. So basically, it calculates the sum from this particular range to this range. Got it? So from 1 to 100, you are just calculating the sum. So summation stands for calculating the sum. All right. Okay. So here, if you see the I value, if I take an example, the I value starts at 1, right? And it goes till 100. So it starts at 1, 1 plus 2 plus 3 plus, and it goes till, like, at the end 99 plus 100. So all the values between, including 1 and 100, all the values from 1 to 100 will calculate the sum, right? Okay, so let's do some problems on this. Let's do some questions, then you'll be able to understand it really quickly. Okay, so okay, let's take one example. Let's take a smaller example. Okay, so let's say summation of I equals to 1 to 5. I. What will be the answer, guys? Can you guys tell me what will be the answer quickly in the chat? So it will be 1 plus 2 plus 3 plus 4 plus 5, right? So in total, it will be 10 plus 5, 15, right? It will be 15. Okay. Now let's do some questions on it. Let's solve some problems, right? Okay. Can you guys tell me what will be the answer for this? Can you guys tell me what will be the answer for this? Great. You guys are smart. Okay. So let's break it down. So you'll have to calculate for I equals to 1 plus I equals to 2 plus I equals to 3 plus I equals to 4 plus I equals to 5, right? Okay, so how will you calculate it? But this time it's not I, right? It's not I. It's, what is it? It's I square. If you notice, it's I square, right? So if I write 1 square plus 2 square plus 3 square plus 4 square plus, sorry, 5 square. So what will be the answer? If you do it, 1 square will be 1, 2 will be 4, 3 will be 9, 4 will be 16, and 5 will be 25. So if you do the total, if you add all of this, what will you get as answer? What will you get as answer? That is 5 plus 9, 14 plus 16. What is 14 plus 16, guys? 30. 30 plus 25, that is 55. Okay. Any doubts in this? Any doubts in this? Any one of you? Clear? All right. So let's go to the next question. Let's go to the next question. So what will be the answer for this? Summation of I equals to 1 to 3, but I cube. This time I cube. We are doing I cube. A lot of answers I can see. Great. So I will be moving in the range from 1 to 3, right? I will be moving in the range from 1 to 3. So we'll have to calculate for I equals to 1, right? Plus I equals to 2 plus I equals to 3, right? If you apply this, you have to apply cube over here, right? This time. So 1 cube plus 2 cube plus 3 cube. So what will be the answer? What will be 1 cube? 1 cube will be 1. What will be 2 cube? What will be 2 cube? 8, 2 to the 4, 4 into 2, 8. Yes. 3 cube, 3 into 3 into 3, that is 3 3 is a 9, 9 into 3, that is 27. And what will be the sum? 36. Great. You guys are smart. Okay. Shall we solve more questions? Should I give more examples, guys? Okay, so let's take few more examples. So let's take some difficult examples. Okay. All right. So summation of I equals to 1 to 4, right? From 1 to 4. This time it is 2 into I plus 5. This time it is 2 into I plus 5. So I would recommend everyone, if you don't have a pen paper with you, quickly take a pen paper with you. Quickly. I'll give you 1 minute. Just figure out some pen paper with you. So I won't be going into too much theoretical stuff. Rather than we'll be solving questions and trying to understand it, right? So you can take pen paper with you. So guys, whenever I give you a problem, you can solve it with me. Don't worry, it won't be like too much mathematics, complex mathematics, simple basic mathematics that is required for programming. All right. Few of you guys have figured out the answer. Okay, so think always in this way. See, summation of 1 to 4, right? Summation of 1 to 4 means you'll have to calculate for I equals to 1 plus I equals to 2 plus I equals to 3 plus I equals to 4 this time, right? But what are you doing this time? When I equals to 1, so what will be the formula, like if you write down this, that is 2 times 1 plus 5, right? Plus 2 times 2 plus 5 plus 2 times 3 plus 5 plus 2 times 4 plus 5. Okay. So how can I expand this further? Yeah, the answer is 40. So can I say that, yes, I can take 5 common, right? I can take 5 common. So I can do like this, right? So it is 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus how many 5s are there? How many 5s are there? There are 4 5s, right? So 4 times 5. So since there are 4 5s, okay. Now if I write it down, so this will be 40. 4 into 5 will be 40. No, it will be 20. 4 5s are 20 plus 2 4s are 8 plus 2 into 3, 6 plus 2 to the 4 plus 2, right? So it's that simple. It's not that hard. It's not very complex. It's very simple mathematics, basic school mathematics. And if you sum this, that is 4 plus 6, 10, 10 plus 2, 12 plus 8 plus 20. In total, it would be 40, right? Okay. Understandable? Any difficulty? Understandable? Any difficulty, any one of you? Yes, cool. All right. Okay, this is basic math, not very complex. Okay, I'm not teaching discrete mathematics or something. It's very simple. Okay, so now let's go to the next question. Okay, so what will be the answer for this? What will be the answer for this? Quickly, guys. This one I'll explain, then you'll get it. Okay, this time it's summation of I equals to 1 to 3, right? Summation of I equals to 1 to 3, 2 times I square plus 3 times I, 3 into I, right? So see, I'll have to calculate for I equals to 1 plus I when I is equals to 2 plus when I equals to 3, right? Okay. So now if I substitute I in this, so how will it look like? Let's substitute I in this formula. So it will be 2 times I square. So I is 1 first plus 3 times 1 since I is 1, right? Okay. Plus 2 times 2. Okay. This should be like this. Okay. No, 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 no. It's false. Okay. Now what is the next step? What is the next step? Yes. Square plus 3 times 2 plus when I equals to 3, it will be 2 times 3 square plus 3 into 3. Clear? I just substitute the value of I in this equation. Got it? Okay. Now what is the next step? It's simple. It's simple. So what is the value for this? What will be the value for the entire statement? Yes, that will be 5. Okay, what will be the value for this one? Quickly, guys, what will be the value for this one? How 14? How 14? Yes, that is, see, 2 square is 2 square is 4. 4 to the 8 plus 3 into 2, that is 6. So 8 plus 6, that will be 14, right? And what will be the value for this? Okay, what will be 3 square? What will be 3 square? What will be 3 square? 9. 9 to the 18 plus 3 into 3, that is 9. So 18 plus 9, that is 27. Now understandable? Now understandable? All right. So the answer is 46. So 5 plus 14 plus 27, that is 46. All right. I hope you guys are able to understand this if you are not from tech background also. Simple basic school mathematics. Just we are just revising it. Okay. All right. So summation is done. Anyone has doubts in this? It's simple basic mathematics, right? Why, like, see, summation of I equals to 1 to 3 means I will be in the range from 1 to 3. So you'll be finding the sum from 1 to 3, right? But what is the expression over here? That is 2i square plus 3 into I. So if you substitute the value of I in the sequence, so it would look something like this. So you just break it down. That is 1 square into 2 plus 3 into 1, that is 5. 2 square, that is 4 into 2, that is 8. 3 into 2, that is 6. And 3 square, that is 3 into 3, 9. Into 2, that is 18. And 3 into 3, that is also 9. So 18 plus 9 will give you 27. 8 plus 6 will give you 14. The sum of it is 46. Third step is basically you're just breaking it down, right? You're just calculating the sum. All right, cool. I hope this is understandable. Third question not understandable. Why? Third question is simple, right? See here also what you are doing. I is in the range from 1 to 4. I is in the range from 1, 2, 3, 4. So you just substitute the value of I in the sequence. So wherever I is present, you just substitute the value, right? So 2 into 1 plus 5, 2 into 2 plus 5, 2 into 3 plus 5, 2 into 4 plus 5. Now, if you see 5, you have common everywhere, right? 5 is common everywhere. So how many 5s are there? There are 4 5s in total. So that is 4 into 5 I'm taking as common. Now, if I remove it as common, what is the remaining expression? That is 2 into 1, 2 into 2, 2 into 3, and 2 into 4. So 2 into 2, 2 into 1 is 2, 2 into 2 is 4, 2 into 3 is 6, 2 into 4 is 8, and 4 into 5, that is 20. The sum of total is 40. I hope this is clear now. I hope this is clear now. All right, cool. Okay, so let's move to the next symbol, that is product. That is product. See, what is the difference between sum and product? What is the difference between sum and product? So let's try to understand that. Let's try to understand that. Okay. So if you see, what symbol is this, guys? What symbol is this? Pi, right? Okay. The product notation represented by the Greek letter pi is used to denote the multiplication of a sequence of number. So previously, when you had summation, what were you doing? You're finding the sum of that sequence, right? Here, when you have pi, what will you do? You'll find the product of the sequence of numbers, right? You'll find the product of the sequence of numbers, right? Got it? Clear? Any doubts? All right, cool. Let's move ahead. Okay. this operation multiplies all the numbers in the sequence together. So example of product, to find the product of the first five natural numbers you would use. So how will you write it? How will you write it? That is product equals to pi of I equals to 1, pi of I equals to 1 to 5 I, right? Okay, this represents the multiplication of numbers from 1 to 5. Okay, so let's break it down. Okay, so here when you're doing product, right? When you're doing product, so what will you do? So pi of I equals to 1 to 5 I would look something like this. So here you'll have to find the product of I equals to 1 into I equals to 2 into I equals to 3 into I equals to 4 into I equals to 5, right? So if you find the product of it, that is simple. 1 into 2 into 3 into 4 into 5. What will be the answer, guys? What will be the answer? That is 2, 2 into 3, 6, 6 fours are, what is 6 fours are, guys? 24, 24 into 5, it will be 120. It will be 120. Any doubts? Any doubts? No, it's not factorial. We'll discuss factorial later. Yeah, it's quite similar to finding factorial. Basically, you're finding the product of a sequence, right? You're finding the product of a sequence. So in summation, what were you doing? You're finding the sum, right? You were finding the sum. Here, you're finding the product. Here, you're finding the product of a sequence. Means there you are using plus, here you will be using multiply. Got it? Yeah. Pi of I equals to 1 to 5. 2 from 1 to 5. That's how we read it. I. Yes, we can start from 4. We can go till 5. It's up to you how you want to take the sequence. I have taken one so that it's simple to understand. All right, great. Okay. So can you guys tell me what will be the answer for this? Can you guys tell me what will be the answer for this? Yes, yes, you can do that. All right, cool. So let's see. So I is in the range from 1 to 3. All right, I is from going from 1, I equals to 1 times I am writing full stop. So I equals to 2 times I equals to 3. So if you substitute the value of I into the sequence, how would it look like? How would it look like? Quickly, guys. Answer also you guys calculated. You guys are sitting with calculators or what? Okay. Or using pen and paper. Are you guys using calculators or using pen and paper? Mobile. Array, wow, smart kids. Acha. Try to do it with hand so that your mathematics will also improve. Okay. So if you break it down, so if you write it down, the sequence, so it will be 2 times 1 plus 3 times 2 times 2 plus 3 into or times. You can say both of it, right? Okay. Into 2 times 3 plus 3. So what will be the answer, guys? Quickly. So 2 times 1, 2 into 1 plus 3. What will be? What it will be? 5. 2 times 2, 2 into 2, 4 plus 3. 4 plus 3 is 7. Great. 2 into 3. 6 plus 3, that is 9. Array, it should not be plus, this should be into. So I'll be multiplying it instead of finding the sum. Okay. 5 into 7 is 35. 35, 9. 9 into 35. What it will be, guys? So let's do the math. 9 5s are 45. Great. So I have 4. 9 3s are 27. 27 plus 4, that is 31. So my total answer is 315. All right. So my total is 315. Any doubts in this? Any one of you? How did I calculate it? See, it's simple. Previously, in summation, you're finding the sum of the sequence. Here, you're finding the product of the sequence. Here, you're finding the product of the sequence. All right. Okay. So let's do one more question. So what will be the answer for this, guys? What will be the answer for this? Okay. All right. Quickly. Calculate it quickly, guys. Okay. Some of you guys said 360. Okay. See, pi product of I equals to 0 to 5, 3i. It's not 0, 0, 0, 0. Acha, theek hai. So let's break it down, guys. Let's break it down. So you're starting from I equals to 0, right? So I equals to 0 times I equals to 1 times I equals to 2 times I equals to 3, right? So if you write the sequence, so it is 3 into 0, right, into 3 into 1, 3 to 2 into 3 into 3, right? So what is 3 into 0? What is 3 into 0? Exactly, that will be 0. That will be 0. So anything multiplied by 0. So no matter whatever the value it gives, no matter whatever the value this gives, right? No matter whatever the value this gives, anything multiplied by 0 at the end becomes what? 0. So the answer for this is 0. Got it? Anything multiplied by 0 becomes 0. अरे 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 हाँ तो till 0 1 2 3 5 till 5. See, if you take anything multiplied by 0, see, since I didn't take it because anything multiplied 3 0 is 0 into 0 is 0. So anything if I multiply, no matter whatever value I get it over here, no matter whatever the value I get over here, so anything multiplied by 0 becomes 0. Okay, cool. So let's move to the next question, next symbol, that is absolute value. That is absolute value. It is also known as what? Mod. Mod of, so here it is mod of x, right? Here you can say it as mod of x. So let's see what is it. The absolute value of a number, right, is its distance from 0 on the number line, distance from 0 on the number line without considering the direction, right? It's often used in situations where only the magnitude of the number matters, irrespective of its sign. Only the magnitude of the number matters, irrespective of the sign. So here is an example of the absolute value. The absolute value of negative 10 is 10 because negative 10 is 10 units away from the 0 on the number line, right? Okay, so if let's say I say that mod 10, okay, I'll change the color. Okay, if I say mod negative 10, okay, mod negative 10, what will be the answer? What will be the answer, guys? Exactly, it will be 10 only, right? It will be positive 10, right? Yes. So what is the definition for this? What is the definition for mod? So pay attention closely. Mod A equals to, let's say if the value is a negative value. Okay. If it's a negative value, right? If A is less than 0, right? If A is less than 0, you multiply it with minus, right? If A is negative, you multiply it with minus, right? If A is a positive value, means if A is greater than or equals to 0. If A is greater than or equals to 0, you don't need to do anything. Got it? Got it? So if in the case of 10, how do you convert it? So basically negative 10, if you want to mod it, so minus into minus 10. So it will be plus 10. It will be positive 10. So it's simple. So it's completely different. In programming, there are two different mods. If you see the symbol, this is what you're referring to. And there is another symbol that is known as the modulo operator, right? This is to find the remainder. This is to find the remainder. That is some different thing. This is mod. This is mod, and that is modulo operator. That is to find the remainder of it. Okay. All right. This is the definition. Mod A equals to, if A is less than 0, you multiply A with minus. If A is greater than or equals to 0, means if it's a positive value, you just keep the same value. All right. Any doubts in this? This is not mode, this is mod. Mod, or you can say absolute value. To find the absolute value, when you start to learn any particular language, let's say in Python, you can write ABS, so it will give you the absolute value of two different. If you're subtracting a negative value, like if you're subtracting a value and you want to mod it, so you can use ABS. And in JavaScript, you can use math.apps, ABS, math.abs. So you learn all these things in the upcoming session. So don't worry of that. This is just to give you an overview of it. This is just to give you an overview. So what will be mod of 5? What will be mod negative 5? It will be 5. Okay. What will be mod 5? It will be 5. So if it's in negative, you're just converting it to an absolute value. Clear? All right. Cool. Okay. So the next important symbol is factorial. So factorial, you are going to see this throughout your DSA journey. You will be seeing this factorial question uh, many times. So it's important to understand factorial, because factorial, you can do it iteratively, you can do it recursively, you can solve it using DP also, right? So why DP? Like those all stuffs, don't worry, you'll be learning in the upcoming session, like in the higher units. But right now, basics is important, right? Okay. So let's try to understand what is factorial first. Okay. Factorial is defined only for non-negative integers, means non-negative integers. Okay. So can you guys tell me what is the difference between positive numbers and non-negative numbers? Can you guys tell me what is the difference between positive numbers and non-negative numbers? Not the spelling. Okay, my spelling. What spelling you're saying? No, not only the spelling is different. I thought you were saying that my spelling is wrong. Yes. So when you think of positive numbers, right? When you say positive numbers, right? So if you say positive numbers start from where? Exactly. It starts from 1, 2, 3, and it goes on, right? And non-negative numbers, non-negative numbers, right? Non-negative means it starts from 0. So it's 0, 1, 2, 3, and so on. Got it? 0, 1, 2, 3, and so on. Is this clear? Difference of positive and non-negative numbers? So factorial is defined only for non-negative numbers. So only for non-negative numbers. Got it? Clear? Any doubts? No, no negative numbers, no numbers less than 0. All right. Okay. So can you guys tell me what will be, yeah, you guys have already learned this in your schools. Like, what is 0 factorial? What is 0 factorial? Exactly. That is 1. All right. Okay. So if I want to calculate further ahead, so what will be 1 factorial? 1. What will be 2 factorial? Yes, 2 into 1. What will be 3 factorial, guys? What will be 3 factorial? What will be 3 factorial? Yes, that is 3 into 2 into 1, 4 factorial, 4 into 3 into 2 into 1. What will be 5 factorial? Yes, 5 factorial will be 5 into 4 into 3 into 2 into 1. Right? Okay. So can I write 5 factorial as 5 into 4 factorial? Because see, 4, 3 to 1, 4, 3 to 1. Yes or no? I can write it, right? Similarly, can I write 4 factorial as 4 into 3 factorial? Yes or no? Yes or no? So if you look at it, see, 3 into 2 into 1 is basically what? 3 factorial, right? So if you look here, 4 into 3 into 2 into 1 is what? 4 factorial. So I can write it this way, right? I can write it this way. So important note, the formula for factorial is, let's say if you want to calculate n factorial, so what will be the formula for n factorial? Exactly. N into n minus 1 factorial, right? So this is important. You need to remember, you'll have to apply this in the questions which are related to factorial. So n factorial equals to n into n minus 1 factorial. Got it? Clear? Any doubts? Simple? Don't worry, I'll take it at the end of the session. See, 0 factorial is 1, 1 factorial is 1, 2 factorial is 2 into 1, 3 factorial is 3 into 2 into 1, 4 factorial is 4 into 3 into 2 into 1. But if you notice, 3 into 2 into 1 is 3 factorial. Yes or no? It's 3 factorial. So can I write it this way also? 4 into 3 factorial? Yes. If you see, 5 factorial is 5 into 4 into 3 into 2 into 1. If you see 4 into 3 into 2 into 1, I can write it as 4 factorial. So I can write 5 factorial as 5 into 4 factorial. So let's say if you want to find 5 factorial, right? If you want to find the 5 factorial, so it will be 5 into 5 minus 1 factorial. So 5 minus 1 factorial would be what? 5 into 4 factorial. 5 minus 1 is 4, right? So 4 factorial. Got it? Now clear? I can break it down. All right, cool. Okay, so let's move to the next question. This is really important. This is like important formulas in permutations and combinations. So we'll be looking into two important formulas in permutations and combinations, right? Okay. Before going into formula and stuff, a lot of formulas and symbols you guys have learned so far, right? Okay. Can you guys tell me which pizza do you like? Homemade pizza or the pizza from Pizza Hut or Domino's? Which pizza would you like? Domino's home. I would prefer like homemade, made by mom. How many of you guys have not eaten a pizza so far? How many of you guys have not eaten a pizza so far? Okay, not eaten. Okay, all right. When you will get a job, we'll eat it together. Don't worry, we'll eat it together. Okay, all right. Okay, so I would prefer homemade pizza. I would prefer homemade pizza over Domino's or any other like brand. Okay, so it looks good. Like see like the cheese is like dropping from the pizza, but I would prefer a homemade pizza by my mom because it's much more better and healthy, right? Okay, all right. So now let me ask you one question, guys. Now let me ask you one question. Okay, let's say your mom is making pizza, right? Let's say your mom is making pizza, and the available toppings are corn, onion, capsicum, mushroom, and paneer. Okay, five types of toppings you have at your home. Now you ask your mom that mom in a pizza add only three toppings because if you add all the five toppings, it feels really bad, right? See, how would it feel like to eat corn, onion, capsicum, mushroom, and paneer together? Yes or no? There are five toppings. How many? See, corn, onion, capsicum, mushroom, and paneer. So in total, how many toppings do we have? We have five toppings, right? Okay. In how many different ways a pizza can be made with three toppings in a pizza? So you ask your mom. So in a pizza, just add only three toppings. So in how many different ways a pizza can be made? Most of you guys remember the formula? Yes. So this is an important formula that is related to permutations and combination, right? So here, if you notice, right, you have five different toppings. You have five different toppings, yes or no? And how many toppings can be added in a pizza? You have told that three toppings in pizza, right? At a max, three toppings in a pizza, and that combination can be anything. That combination can be anything. It is random. She can add any particular combination. You haven't restricted her or you haven't told her that you need to put only corn, onion, capsicum together. You can combine anything. She can combine anything together. Yes or no? All right. So here the order doesn't matter, right? Here the order doesn't matter. Yes or no? Yes or no? So we can use any different combination. We can use any different combination, any particular combination. You can add a corn with capsicum with paneer. You can add a mushroom, capsicum, corn. It's up to her, right? But you have given the limitation to a mom. In a pizza, at a max, at maximum, how many toppings you can put? She can put. That is three, right? At max. Okay, understood this? Understood this? Don't try to figure out the solution. Just wait. I'm asking you questions, right? Okay. Any doubts, anyone? Any doubts, anyone of you? Cool. All right. Okay. Let me ask you one more question. Let me ask you one more question. Okay. There is Batman, Superman, Thor, The Flash, and Hulk. Okay. Are running in a race. In how many different arrangements of first, second, and third place are possible? So, how many people are running? So, five superheroes are running. Five superheroes are running. Yes or no? And how many positions are there? Three. That is first. Either a person can come first, either a person can come second, and I or he can come third, or he can't win any prize. Yes or no? So here Flash will all obviously win. You guys know already. Flash is very fast. If you watch if you read comics or watch movies, Flash will always win, right? So Flash is fast. So Flash is always first. But there can be a possibility, right? Flash might be slow one day. He's not well. Yes or no? So Right now, you have five superheroes, right? You have five superheroes, right? And there are only three possibilities, right? So you need to do those arrangements, right? You need to do those arrangements. So how will you do that? I don't know. See, let's say for the first position, so how many possibilities are there for first position? That is five. Yes or no? For first position. So let's say if one person gets first, can he come second? Let's say one person comes first, right? Can he come second? No, right? Obviously not. So if we deduct that person, how many possibilities are there for second person? Exactly. Four possibilities are there. Four possibilities. For third position, how many different possibilities are there? Exactly. See, one person got first, one person got second. Now, how many people are left? Three. Either of these three people will get the third position, right? Clear? Any doubts? Got it? Both the stories. See, here, what did in the previous question? What didn't matter? The order didn't matter, right? Order didn't matter. But here, the order mattered, right? Here, the order matters. But here, the order doesn't matter in the above question when you're making a pizza because you can combine anything. Here, the order matters. Let's say one person got first, he can't come second. So you'll have to keep that. Yeah. See, in simple cases, I would say, simple terms, I would say, yes. Thank you. Who was that? Jan Prakash. Yes. Simple word, I would say. Here, I wouldn't say a repetition of one particular thing. The sequence can be anything, right? Here, any combination can be there. But here, you'll have to think of permutation, right? Here, you'll have to think of permutations. Yes, I'll come how to solve it. I'll come to how to solve it. So there are two important formulas for this, right? When the order doesn't matters, right? So you'll go with the NCR formula. This is for combination and this is for permutation, right? Both are important formulas. Just remember these formulas. This is basic maths. Like it has already been taught to you in school. If you don't remember, try to recall it. It won't be like for every question you'll require this. There might be questions that you'll be requiring this. So it's better to know about it, right? Yes or no? In class 11, 12th, you guys have been taught. 10th also, I think some of the boards it has been taught. All right, cool. So the formula for NPR, basically, when the order matters, right, is n factorial by n minus r factorial, right? N factorial by n minus r factorial. And for NCR, it is n factorial by n minus r factorial minus r factorial, right? N minus r factorial by n factorial by n minus r factorial minus r factorial. I'll come to that. What is NPR and NCR? See, if so, which one will you go with NPR and which one will you go with NCR? So for this, the order matters. For this, the order matters. Yes or no? Basically, it matters, right? So you'll go with NPR. NPR because you want to figure out the permutation, right? So how many people attempted the race? Five. P. And how many positions were there? That is first, second, third, right? So three medals were there. So it will be 5P3, right? If you substitute it into this formula, so it will be 5 factorial by 5 minus 3 factorial. Substitution is clear? So in the above question, pizza wala question, what it was here, the order didn't matter. You need to figure out all the combination, right? You need to figure out all the combination. Here the order doesn't, you don't care about the order. So here it will be 5c, how many toppings can you add? 3 toppings. How many toppings do you have? 5 toppings. Got it? So it will be 5 CR. So if you substitute it, it will be 5 factorial by 5 minus 3 factorial minus 3 factorial. Okay. So can we break down this more? Can we break down it further? Let's see. Let's see. Okay. So basically, what is 5 factorial? What is 5 factorial, guys? Come on. That is 5 into 4 into 3 into 2 into 1. Yes or no? Yes or no? And what is 5 minus 3 factorial? What is 5 minus 3 factorial? So 5 minus 3 is 2. So what will be 2 factorial? Exactly. That is 2 into 1. That is 2 into 1. So what will happen now? 1 and 1 will get cancelled. 2 and 2 will get cancelled. So what is the answer? 5 into 4 into 3. That is in 60 different ways. In 60 different ways, there can be outcome. When there is order, right? When there is, you have to take care of the order. Basically, when you are calculating the permutations, right? Got it? And if you look at the second one, when you are looking for the pizza one, right? So in how many different ways your mom can make pizza? That is 5 factorial. That is 5 into 4 into 3 into 2 into 1 divided by 5 minus 3 factorial. What is 5 minus 3 factorial, guys? 2 factorial. So that is 2 into 1. What is it? This is not minus. This is into. This is times. Sorry. Okay. So times into 3 factorial. What is 3 factorial? That is 3 into 2 into 1. So what will happen next? What will happen next? Yes, exactly. This 2 and this 2 will get cancelled. This 1 and this 1 will get cancelled. This 3 and 3 will get cancelled. Yes or no? 2 ones are 2, 2s are 4. So 2 is remaining over here. So it is 5 into 10 by 1. So it is 10 divided by 1. So what is 10 divided by 1? That is 10. So in 10 different ways, your mom can make pizzas. And in 60 different ways, Batman, Spider-Man, Flash, Hulk can win the race. Got it? Okay. Anyone has any doubts? Anyone has any doubts? Okay, I'll unmute one person. I'll unmute one person. Preet, can you unmute yourself? Preet, can you unmute yourself? Can you raise your hand, Preet, if possible? Preet Mudeval. Preet, I guess, who was it? Preet Mudevar, right? Yeah, Preet. Can you speak? I have unmuted you.
Okay. So
Yeah.
actually, I still have doubt that where to use permutation and combination based on situation.
See, the example I give you, right? When your mom was making pizza, right? She had 5 toppings, right? And you asked your mom that at max you can put 3 toppings only in one pizza. Got it? So in that scenario, she can add any of those 5 toppings, right? She can add corn, she can onion, she can add capsicum, or she can add corn, onion. Any combination is working right there, right? But when you are thinking of permutation, think of a race, right? Where let's say 5 people are running a race and there are 3 medals, first, second, third, right? So let's say if there are 5 people, there are, for the first place there are 5 permutations. For the second place See, one guy, if he got first, can he get second? No. So four people will be left. Yes or no? So for the third place, how many people will be left? Three people. So that is 5 into 3, 4 into 3. So basically the formula to calculate is n factorial by n minus r factorial. So whenever you have to take care of the order, you'll think of permutation. Whenever you don't have to take care of the order, you'll think of combination. Is it clear now? Uh, Preet, I think you unmuted yourself. Preet, is it clear? See, when you're making pizza, you can add anything, right? But at max three toppings here. So there are combinations of different toppings. But here, what is the scenario when you're running a race? Preet, am I audible? Preet, hello, we can't hear you. Can you guys hear Preet?
Sorry, you are audible.
Yeah. Have you understood the logic?
Yes, sir.
All right, cool. Okay. So thanks, Preet. We'll move to the next slide. That is, we'll start with pseudocode. Okay. So far, so good. Any doubts in any of the step, any of the things that we have learned so far before moving into pseudocode? You can ask quickly in the chat. No. Okay. So the time is 12:39. All right. I have given so many examples, right? I have given so many examples. See, NPR and NCR comes into place when you need to find permutation or combination. So let's say if you want to take care of the order, right? So you'll go with what? You'll go with permutation, NPR. If you don't want to take care of the order, you want any different combination, you'll go with the NCR. Just remember these two formulas. It's simple, not that hard. That is NPR equals to, these two formulas are really important. NPR equals to n factorial by n minus r factorial. NCR equals to n factorial by n minus r factorial into r factorial. It was asked, sorry, third position. So why are you considering first two? In second position, first, second, third place, right? There are three positions. So all those arrangements you need to figure out. See, the only thing is here, see, you have a particular order. The first person, the first for getting first, there are five different people. So there are five people running the race, right? So there is a possibility that out of five, any person can win. But let's say one person got first. He crossed the finish line. Okay, I'll give you one more example. Okay. So let's say five people are running the race. This is the finish line. Okay. One person crossed the finish line, right? So how many people are left right now? Exactly four people, right? So let's say one more person crossed the finish line. How many people are left for the third position? Exactly three people. So here the order mattered, right? Order mattered. So that's why you'll be going with permutation. In the above question, the order didn't matter. So that's why you're going with combination. That you can read and understand. Okay. So quickly we'll take 1 minute break. Then I'll drink water and come. So meanwhile, you can read what is pseudo, or you can also take a quick, not lunch break, 1 minute drinks break. Get water. All right, guys. Is everyone back? Yes, great. Mm, all right. Okay. So first, let's try to understand what is the meaning of pseudo. Pseudo means basically not genuine, spurious or sham. We are talking about real journalists are not pseudo kind. Pseudo means it's not real basically. So in programming, if you see, uh, pseudo code means it's not specific to any particular language, right? So if you see, whenever you're going to higher units, right? Whenever you're going to higher units, see, some of you might be writing the code in JavaScript. Some of you might be writing the code in Python. Some of you might be writing the code in Java. Some of you guys might be writing in C++, right? So see, I also write DAs, like whenever I'm solving DAs, I write in Python, solve in Java, I solve in JavaScript also. So there should be some common terms, right? Basically, like so that everyone can understand. Everyone can understand anything because let's say I'll take one example. I'll take one example. Let's say there is Lokesh and there is Saurav. Okay. Saurav writes code in Java and Lokesh writes code in Python, let's say. Okay. So Saurav, will Saurav be able to understand code in Python? No, right? And will Lokesh be able to understand code in Java? No, exactly no. So that's why we use pseudocode in programming, right? We use pseudocode in programming. Okay. So let's try to understand what is pseudocode in programming. Okay. So pseudocode is an informal high-level description of the operating principle of a computer program or other algorithm, right? It uses the structural conventions of a normal programming language, but is instead for human reading. So basically, it's quite simple. It should be readable by any human, right? Rather than machine reading. So when you're writing code in any particular syntax, why are you writing that? You're writing that so that the machine or the computer can understand it, right? But pseudocode is for humans to understand, right? Pseudocode essentially serves a bridge between the problem solving phase of a program development and the actual coding phase, right? So let's say when you're writing some logic for any application, right? So you'll write the pseudocode first. So this should be the logic, this should be the logic, this should happen next, right? Then only you'll convert it to some kind of syntactical code, right? So first, what will you do when you're a programmer? You'll write a pseudocode, right? He'll write a pseudocode. Then you'll either convert it into whatever language you're writing, C++, Python, any other language. Let's say it can be Java, TypeScript, JavaScript. You'll be mostly doing coding in TypeScript, JavaScript, Python. These are all the possible language, right? TypeScript, JavaScript, C++, Python, uh, Java. I think no other languages you guys use over here. Yeah. Syntax is basically the structure of a code. I'll come to that. Don't worry, you'll learn all of this stuff in the upcoming units also. It allows the developers, basically, it allows the developers to express their solutions in a way that can be easily understood by others without the need for specific syntax knowledge of any particular programming language. Got it? So basically, when you write language, right? So the syntax means uh, the example for syntax I would give is like, let's say there is a Chinese person, right? So the best real world example I will give you. Let's say there's a Chinese person, right? And let's say there is a mm, any other language. Can you guys give me? Not British. No, 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 no. Any other like which is not rest. It shouldn't contain English characters. Yes, Tamil. Great. Okay. Right. So the best example, real world example I can give you is that let's say there is a Chinese person, right? And there is a Tamil person, right? Can this Chinese guy understand whatever the Tamil guy is writing? No, he can't understand. Can this Tamil guy understand what is this Chinese person is writing? No, exactly not. So, what are the common terms for both of them that both of them can understand? Possibility of both of them understanding. Yes, exactly. English. And that is pseudocode programming. Got it? Clear? All right, cool. So let's see why use pseudocode. Why to use pseudocode? So basically, if you see clarity, the first point is clarity. Pseudocode focuses on the logic of the algorithm without being distracted by the syntactical complexities of a particular programming language. Universality, right? Universality. It can be understood by programmers who know different programming languages. It's not bound to any one language, right? It's not bound to any one language. Planning. Writing pseudocode is a good way to map out exactly what you want your code to do before you start getting into details of coding. Communication. It is useful for communicating algorithmic ideas to others, particularly in educational settings or development teams. So basically, if you want to communicate to a person who's working in a different team, is working with Java and you're working with JavaScript. If you want to communicate with this is the algorithm that I'm thinking we can add to our website. So that's how you can use pseudocode to communicate with them. Got it? Or when you're giving DSA interviews, you'll be asked to write pseudocode only. Sometimes they might ask you the preferable language you want. You can write it in that, or you can write pseudocode. It's up to the interviewer. Sometimes they ask pseudocode only. Sometimes they ask specific language. Okay, but it's really important to understand how to write good pseudocode. Okay, so how to write pseudocode in a programming, education, and software development? Pseudocode acts as a critical step in design process, bridging the gap between problem understanding and actual coding. It helps to outline the logic and structure of the code without getting bogged down in language specific syntax. Right? Just think, like, see, if a Chinese person is coming and he's stuck with Tamil, will he understand anything? No, right? So the Tamil guy needs to speak English to the Chinese person, right? Or let's say if a Tamil person is going to China, so he won't understand, right? So that's why in programming, pseudocode comes into picture. Let's explore how effectively to write pseudocode using clear conventions that mimic real programming concepts. Key elements of pseudocodes: variables use descriptive names that make sense. Operations describe what the code is doing in straightforward way, like increment count by one, calculate the sum of x and y, or find the maximum value. This uses plain language to express logic. Conditional statements. There are these are the decision making structures of pseudocode. Use terms like if, then, else, and optionally else if to control the flow of the pseudocode logic. Right? Because these all things contain in all the programming language and everyone can understand by reading it quickly. Right? So in the upcoming sessions, mostly Venu sir will be teaching you guys in the pseudocode only. Right? So guys, it is easy to understand for you, and implementation time IS will be helping you out if you're stuck with syntactical errors that time. But during the classes, pseudocode will be like the main thing. You'll be explained everything using the pseudocode. Structuring your pseudocode: begin and use these words to define the start and end of your pseudocode. Indentation: like in actual coding, use indentation to define the scope of loops and condition statements. Comments: while not mandatory, comments can be added for clarity. See, comments are not mandatory, but I'll comments if you can add what is the thing that you're trying to implement. But indentation is really important. Why indentation is really important? Let's say if I'm writing this, right? If I'm writing this code, okay, I'm writing this code. If A is greater than B, okay, I'm writing the rest of the code in the same line. Okay. Now I'm writing if B is greater than C. I'm writing the rest of the code in the same one single line. Will you guys be able to understand? Will you guys be able to understand? No, right? No, right? So it will be hard to understand. So follow proper indentation. Let's say there is a niche statement. The next line should start from here. Like there should be one tab space, right? There should be one tab space. If you're writing an else statement, right? See, the else statements, whatever it is, it should not start here. there should be some space over here. Basically, IDEs or the IDEs, when you're writing code, it automatically gives you that space. When you hit enter, it automatically enables, like, gives you that space. Don't worry, pseudocode is a term, means you're writing a code, something that can be understandable by anyone, any programmer who is writing in any particular language. So rough code. We'll take examples. Don't worry. We'll take some examples and you'll understand. Okay. Can you guys tell me what is this following pseudocode doing? Can you guys tell me what is this following pseudocode doing? Okay. So let's break it down. You have input num1, num2, num3, right? It's clearly mentioned over here. It's clearly mentioned over here. What is the begin? What is the end? Yes or no? So you have three numbers, right? So let's say num1 equals to 5, num2 equals to 7, and num3 equals to 3. Okay, all right. So initially you are setting max. You have one more variable, that is max. Okay, one more variable, that is max. Set max to num1. What is num1? Exactly. So max equals to 5. Clear? Step 1. If num2, right? If num2 is greater than max, if num2 is greater than max, is it correct? Is num2 is 7, max is 5, right? Num2 is 7, max is 5. So if num2 is greater than max, then set max to num2. So num2 is greater than max, right? Num2 is greater than max. So what will I do? Set max to num2. So what will you do? I'll update max to num2. That will be 7. Okay, what is the next step? If num3, right? If num3, is num3 greater than max? No, num3 is not greater than max, right? So this condition will be failed. Num3 is not greater than max. Yes or no? Num3 is 3. Is it greater than max, which is 7? No, this is false. This is false. See, here what happened? This condition was true, right? This condition was true. So that's why I updated in this line. But here it is false. So I don't update it. Then at the end, what will I do? I'll just print my max, which is 7. Clear pseudocode now? It's not specific to any programming language, right? You don't know any programming language, then also you are able to understand it. That is pseudocode. Cool. Yeah, this pseudocode, what it does, just figure out given three numbers, figure out the maximum number out of three. Okay. So what does this pseudocode do? Go on quickly. Okay, Rohit. Yeah. Uh, Guys, what time do you have next session? At what time does your next session start? Next class starts? 2:45, right? So if it's fine, right? I'll extend 5 to 10 minutes. All right. So I can elaborately explain. Okay. All right. So now you have two integer A and B, right? You have two integers. Integers means numbers, right? Okay. So you have two integers A and B, right? That is A, one is B. Okay. Set A equals to 5. A you're assigning as 5. Okay. Next step, what you're doing? Step number 2. A equals to A plus 1. A equals to A plus 1. That is 5 plus 1. It will become 6. Right? A has become 6 here. Got it? You're assigning, reassigning, right? A equals to A plus 1. Got it? So you're reassigning A. Clear? Now what you're doing? A equals to A into 2, A times 2. So A was what? A was 6. So 6 into 2, what will happen? 6 into 12. So A equals to A into 2 or A times 2, that is 6 into 2, it will become 12, right? A equals A divided by 2. What is A right now? What is A right now? That is 12. What is 12 by 2? That is 6. So A becomes 6 now, right? Clear so far? Clear so far? Okay. P equals to A by 5 plus 6. So what is A by 5? So A is 6 divided by 5. We'll take the floor by default. So it is 1. It will be 1 point something, but we'll take floor. 1 plus 6. So 6 by 5. 6 by 5 is 1. 6 by 5 is 1, right? So this 1 plus 6. So what is the answer? It's 1 point something, but by default, you'll take floor. You'll take floor value of it. So 1 plus 6, it is equals to 7. So 7, you're assigning to which variable? You're assigning it to P, right? So P equals to A, which was 6 divided by 5, which gave you an answer 1, plus this 6. So 1 plus 6 in total, you got 7 and you're assigning it to P. So P became 7. Vadika, by default, you'll always take the floor value of it. It's not approximate, it's floor value. Have you guys learned about floor and seal values? Not round of round, floor, seal, everything is different. Don't worry, floor is the lower limit. So let's say if you divide 6 by 5, it will be 1.2, right? So basically you're rounding, almost you're rounding, but there is a difference in floor and seal. Seal is up, floor is down. So it will become 1. By default, think of floor only. Okay, don't worry, you'll learn it in the upcoming sessions. What is floor? What is the difference of floor and seal? Okay, in JavaScript classes, you'll learn. Okay, cool. So next, let's take the next question. Okay, so now the next question is you have three variables, integer A, B, C. Set B equals to 40, A equals to 20, and C equals to 20. Got it? Okay. Now, A equals to A plus C. What is A? What is A? A is 20. What is C? C is 20. Right? A is 20, C is 20. So 20 plus 20, A will become 40. So A equals to A plus C, right? So now A will become 40. C equals to C plus A. What is C? C is 20. What is A? A right now is 40, right? A right now is 40. So 20 plus 40, C will become 60. Yes. C will become, what will C become, guys? I don't want the answers. Okay, 60. A equals to A plus C. What is the value of A right now? The value of A is 40. What is the value of C right now? That is 60. Okay, so A equals to A plus C, that is 40 plus 60, that is 100. So what will A become now? A will become 100. Okay. Now C equals to C plus A. What is C? C is 60 plus what is the value of A? What is the value of A? Value of A currently is 100. So C will become 60 plus 100, that is 160. Okay. Now print A plus B plus C. So what is the value of A? 100. What is the value of B? 40. It hasn't changed. What is the value of C? It is 160. So what is the total answer? Exactly. So the total of this is 300. So 300 will be printed. So pseudocode almost it's kind of similar to Python code only, but it's not Python. It's not Python. Okay. Sometimes the instructor might write pseudocode. You might feel the instructor is teaching only in Python, but no, it looks similar to Python. Python code. Python code is also like pseudocode. Okay. Any doubts in this? If number is not given, you can assume any values. Yes. It's pseudocode now. If input is not given, you can assume any values. All right. Okay. Can you guys tell me what is this pseudocode doing? What is this pseudocode doing? Input two positive integers n and m. So n and m are two positive integers, right? They are not negative. So it will be always, what is the difference between positive integers and non-negative integers? So positive integers start from where, guys? 1, exactly. So it will be greater than equals to 1. N and m will always be greater than or equals to 1. Okay. All right. So begin. Calculate the cube of n and store it in the variable cube n. Right. So cube n equals to n into n. Right. So let's say n equals to 2. Okay. N equals to 2. So what will be stored in cube n? That is 2 into 2 into 2. That is 8 will be stored in cube n. Calculate the square of m and store it in square m. So let's assume m equals to 3, right? Square of m equals to m into m. So it will be 3 into 3. It will be 9. So in square m, I'll store 9. If cube n is greater than square m, so what is cube n? What is the value of cube n? What is the value of cube n? That is 8, right? Is it greater than square m, which is 9? Cube n is 8, square m is 9. Is it greater? No. So this condition is not true. So it will come into the else part. It will print what? False. It's simple, guys. You'll be seeing a lot of pseudocodes, then you'll try to quickly read it and quickly understand it. Okay, so let's go to the next. It's up to you. Any values you can do. But the only part is I'm trying to make you understand the pseudocode. Okay, so let's look at the next part, that is constraints in programming. Constraints in programming. Okay, in programming and problem solving, constraints define the limits and boundaries within which solutions must operate. Understanding these constraints is essential for developing efficient and effective solutions that adhere to these specified conditions. Constraints can affect how you design algorithms, optimize performance, handle edge cases, and ensure data integrity. Right? Why constraints matter? Constraints are crucial because they define limits, specify the ranges or characteristics data can have, prevent errors, help in checking and validating data before processing, optimize solutions, right? Optimize solutions basically allow developers to choose the best algorithms or data structures based on the expected size and type of data. Facilitate testing, make it easier to design tests by providing clear boundaries for test cases. Don't worry, these terms might feel very intuitive to you, but don't worry, I'll explain everyone what is constraint in simple language. Okay, so there are 4 or 5 different types of constraints. So one is range constraint. What is range constraint? Specify that a value must fall within a specific range, right? So if I talk about range constraint, right? If I talk about range constraint, so the value of x, right, and integer x must be between 10 and 100 inclusive. This can be written as 10 less than equals to x less than equals to 100. So value of x will be in the range from 10 till 100. It can be any value in between that. Yes or no? The next is type constraints. Specify the type of data, such as integers, strings, or array. Example, let's say a variable name must be a string containing only alphabetical characters. Right? It can also be mentioned that it is only small case characters or uppercase characters. So that is type constraint. Basically, which type of data is been given to you, that is type constraint. The next is size constraints. Limit the size of a data structure. Example, an array ages can have at most 50 elements. This can be represented as length of the ages array is less than or equals to 50. Means it will have at a max 50 elements, right? Okay. Now the next thing is uniqueness constraints. I'll come to that. I'll come to that, everyone of you. Don't worry. Okay. Uniqueness constraints ensure that the data entries are unique within the certain context. So you will be given like in the question, user names in the database must be unique, right? The next is performance constraints. Impose restrictions on the acceptable limits for performance, such as execution time or memory usage. Example, a function must execute within 200 milliseconds. Okay, so I'll give the best example for constraints to you. Okay, I'll give you the best example for constraints. Okay, can you guys give me some names in the chat quickly? We are short of time. Okay, we have Rohit. Go slow, guys. Okay, we have Aman. Okay, we have Mithun. ठीक है? All right. Three people. So Rohit wrote a code that runs in 2 milliseconds, right? Now Aman wrote a code that runs in 0.5 milliseconds, right? And Mithun wrote a code that runs in 1 milliseconds, right? Mithun wrote a code that runs in 1 milliseconds. Now, can you guys tell me, right? Let's say if I put a restriction, the code which is less than or equals to 1 milliseconds will only be accepted. Who all will win the prize? The code which runs in less than or equals to 1 milliseconds. That is exactly Aman and Mithun's code will be accepted. But Rohit's code is fine, it's working, but it takes more time to run, right? So you'll have to optimize the code more a little bit more, right? You'll have to optimize the code a little bit more. So that's the idea of constraints. So if I give you an example, I'll give you a problem that normally comes up in an interview. Don't look at the question, don't look at the problem statement, don't read it. I'm just giving you how constraints are given in question. So when you'll be starting solving questions now, so when you start learning basic DSA, what will happen is you'll be giving the problem, you'll be giving the input, you'll be giving what is the output that you need to print, and you'll be given the constraints. Basically, constraints are what you'll learn what is NQ, AFI, and K and all. Don't worry, all those things will be explained to you. Basically, it is telling you that the value of N can be between or included 2 and 10 to the power 5. The value of Q can be between 1 and 10 to the power 5. So if I give you an example, let's say I'm saying that you have been given uh, an array or some data structure, right? You'll be using data structure, right, to solve questions, right? So the value or the size of that, basically that they're defining, or the value inside the array or the elements inside, what type of data it is, what kind of range it could be in. That is basically constraints. It's not that complicated, but it's really important to look at constraints when you're solving questions so that you write the optimized code or the better version of your code. So the best real world example, if you have time, I can give an example. It's not that important, I would say, but it's important. Like it's not that in depth. You should not know. In the upcoming class, assist in unit 2, when you'll start learning time and space complexity, you learn more about it. This is just so that you can know about it. Okay. So I'll give an best example for it. Okay. Uh, I'll share my. Okay, is my screen visible? Is searching sorted list? Is this visible? Don't look at it. Don't think about it. Okay, I'm just giving a visual example for it. Okay. So there are two algorithms that helps to search something, right? That helps to search something. Don't think about the algorithms. You will learn all of this stuff. What is linear search? What is binary search? Basically, I'll give an idea. Linear search goes for every element and searches every element, while binary search is much more optimized version of searching. Don't worry, it will be taught to you in the upcoming units. Everything in detail will be taught. I'm just giving you a visual representation. Okay. So now let's say if you have a large set of data, okay, now you have a huge set of data. Okay. Now if you see what is the size of your array, if you see the constraints are 0, 1, 2, 179 elements are there, right? If you see 179, so total 180 elements would be there. Okay. Now let's say in this, I'm giving you just a visual example of constraints. No need to worry about the algorithms and all. Okay. Okay. Linear search, just one thing you need to take care. Linear search is slower, binary search is faster. How? I'll show you. Okay. Now let's say I'm searching for 748. Okay. Now I'm running this linear search algorithm. See how slow it is. Every element it's going, right? It's searching for every element. Very slow. Yes or no? But let's say instead of that, I apply binary search. So one thing you understand, if the constraints are big, your algorithm will take a lot of time, and your algorithm takes a lot of time. So there might be a scenario that your code might fail. But if the constraints are big and your algorithm is optimized, means your algorithm is really good, fast. So that's where constraint comes into picture. So here the algorithm is fast. So it divides the array into two. Don't think about the algorithm. It's simple. It will be like explained to you in the upcoming units. How does it exactly works? So here it's fast. So the only point that I want to give to you is that, see, constraints come into picture when, where was I? Okay. Constraints come into picture when you need to see if your algorithm is optimized or not, right? So you can understand how is the input provided. The input, you can understand what is the input has been given and what is the range or size of the input. Range or size of the input. So for that, constraints help. Got it? Got a basic idea. You'll be learning how to use which one, all those in the upcoming sessions. In the next unit. Those are like little advanced stuff. This is just like giving an overview of programming. What are pseudocode? What are constraints? And all. Okay. Now let's do a quick recap. What all things did we learn today, guys? Mathematical symbols. Yes. Sigma, pi. Another thing, factorial. Mod we learned. Yes. We learned about NPR and NCR, right? Pseudocode. We learned basically how to effectively write pseudocode. Yes or no? So we are just giving a basic. We saw basic overview of all of this. These are not. like this won't be like, I would say these are like important things that you should know in program. That was the session about. So then we learned about constraints. So constraints, basically different types of constraints: type constraint, right? Size constraints, performance constraints. So different type, range constraint, yeah, different types of constraints. Okay. So that's all, guys, for today's session. I'll end it, but I'll take your doubts after this for a few minutes. Okay, I'll stop the recording.